let's get reset. What I wanted to do was talk about this thing called tracker. So a problem that we had in guardrail was that error messages were particularly useless when it came to very large specification files. We end up with a pretty much just single strings, right? Like you would expect from either a compiler or something without any context of what file it came from, particularly because the parser that we are using is the OpenAPI standard Swagger parser Java library. So the problem that we have with that is that it doesn't maintain any sort of history. And then additionally, it's actually far more Java idiomatic than would be nice to consume from Scala. So lots of plain Java arrays, lots of nullability. I don't think that there's much exception. I don't think there's any exceptions actually, once you're past parsing the file. But yeah, for just in general, that's the problem that we had to start with. So I ended up writing this thing called tracker based on, there's a couple of different Haskell libraries, IndexedFunctor indexed, there's also control applicative indexed. The idea being, if I have a way to walk a structure and preserve the names that I'm walking into the structure with, then it would be possible to sort of build up this sort of interactive history as I'm traversing into a Pojo without having to have the Pojo actually even know that it was being kind of built, or like accessed rather. So there's a thing called a histomorphism, I think, which allows you to sort of get access to the history of a destructive recursion scheme sort of deal. This is not at all that. This is really born out of necessity, not really obeying any particular laws other than what is most useful for this code base. But with some maybe tweaking and further iteration, this idea can become something more useful to other people. Right now it is largely separated from any particular implementation details, other than the fact that the primary constructor for a tracker is linked to the OpenAPI kind of root object. The idea is that you start with the root, and then as you traverse into things, you can actually kind of build up this history of where you've been. And then as this propagates out into the code base, you end up getting really good error messages. And we'll see that very shortly. So the best way to get started here is to look at, first of all, the documentation for tracker not only exists, but also kind of covers the basic ideas that we're trying to get out of this, right? So if we start with the tracker for an open API, we can see here the syntax is sort of aligned here with tracker being the outermost context. And then inside we can actually see that we're kind of flipping around between different structures for like different types, right? So if we start by initializing a tracker, all we have is a tracker of OpenAPI. It by default has no history because it's just the root element. But if we say downfield into the field called servers, now this is a string that we supply because I didn't want to macro reflect out and try to guess the names of accessors. This is intended to be very closely linked with the actual field in OpenAPI spec. So in this case, we're saying get servers, and this will return a nullable array of server objects in the OpenAPI spec. But interestingly, you can see here that we end up getting a list of server. This is because the tracker implementation for this function called downfield, internally it uses a thing called convincer, which the goal is to sort of massage the data types from Java into Scala. It's not very efficient, but that's really not important here. What's important is that we don't have to worry about nullability, and we don't end up having situations where unexpected behavior seeps in. So in the future, if it turns out to not be useful to default to an empty list in the case of a null field, this would be very easy to change, to remove this kind of fallback of list to option, or rather a none, an option none falls back to an empty list. That can be removed, and then we just have a bunch of type errors all over the place, and we just fix those, and then we've removed this feature. Or maybe we want to add it for new types, and it would be very easy to add it for those as well, because all the infrastructure is sort of in place for this kind of dynamic massaging, but it's still at compile time. There's no reflection in this. So we can actually play around with this in the console and get a better feel for this. So I've just got an example file here. If we set the syntax to Scala, we start with some imports. Main thing is we're going to import cats implicits, because we use cats for some of the type classes, and then we provide our own tracker, indexed functor, and indexed distributive. So indexed functor here allows for a normal sort of functor situation where we end up having an f of an a, and then an f of a to b, like a function from a to b. But we add this additional I, and based on what instance of indexed functor we find, we can actually pull out a different dynamic based on the implementation of whatever this container f is. We can actually pull out a different type for I for each of those. And we end up seeing that, for instance, a map, an indexed functor of map with string as a key, ends up giving us the type I as string. And then in our function f, we're actually taking this string I, this is the key of the string, or the key of the map, and also the value of the map, and then producing some b out of it. But that actually gives us the exact same type as we would have gotten from map, except with the addition of this I parameter. So you can sort of imagine that the key is being consumed, but it's maybe not consumed is the right word. It's being forked, right? So it's being used inside the function, but also the string is preserved in the output of map, because this isn't changing the structure of anything. This is just kind of projecting the key into the map operation, and that gives us the ability to say, for whatever map we're doing, we're actually asking for the key and the value to be considered in the computation for the next value in this structure. Same thing with list, where the I is int, non-empty list as well, and then option, where the I is unit, because we don't really have an index for option, but it's still useful to be able to treat this option in the same way that we treat everything else. And so as a result, we end up with a situation where a lot of the implementations, like for instance, label allows you to say, I need to take whatever the thing that I'm holding, whatever this I is, and I need to turn that into a string. But it only makes sense to turn it into a string for types that sort of have a concept of a label, right? So if I'm indexing into a map, it would be useful to say, hey, I need to just kind of represent this as like a dot notation index into this map hierarchy. But then as soon as we switch over to like a list or an index list, then we switch over to like the sort of conventional square brackets. And so you end up getting something that looks a little bit like a JSON pointer. And the idea behind that is that because Swagger itself is based on JSON schema, that it's sort of natural to think of these things in the form of like dot indexing into, or otherwise, yeah, having that sort of traditional JSON's accessor structure. So yeah, that's why it's structured the way that it is. So we've got that as index functor, and then index distributive allows us to build on index functor and add functions to sort of work around and work within the context of an indexed functor or a tracker. And we'll see that here as well. In particular, trying to traverse over structures with tracker, but also maintaining history while we index into their sort of all the different fields that they have. So let's pull these definitions for these example classes. Okay. Hello, viewer. Just if you have any questions, shout them out. But otherwise, paste. We're just going to construct a foo. Here, the bar field here, this a is an integer, right? So I'm just going to inject a null just to have something that would not normally exist in Scala code bases. And then additionally, baz has a value, which is an array of strings. And this one I'm going to toArray here as well. And that way we can actually test out some of this functionality of converting between different data types from the Java, idiomatic Java data types to Scala data types. So just to construct this thing, now we have this function called, or this value called tex. So x being example, tx is the tracker. As I said earlier, it's not possible to construct a tracker without an OpenAPI specification as the root object. By design, it's not intended to be just sort of start from wherever and then go to wherever you want. Doesn't really matter. It really is intended to have the history preserved from the very beginning all the way out to the root or to the edges. And so by that way, we're sort of prioritizing that use case. But in this case, we're using this clone history function on tracker. The idea behind this is that sometimes you end up with consuming multiple fields, or somehow you end up with something that is spiritually linked with where it came from, but not directly linked. In this case, it would be possibly something like a dereferencing data models from the components. If you pull out a ref, but then you happen to have the actual object somewhere else, and you associate the ref with the object that you've just looked up, it's not technically a downfield. And so maybe it's useful to associate the history of the ref that you pulled with the actual implementation of the data class, right? So that's sort of the idea behind clone history. We're going to use it here just so that we can sort of have a useful interactive way of kind of building these things up or building up these queries. So just to start, if we look with at text.downField and just grab the bar field. So this is to use downfields. It has two arguments. The first one being the name of the field and the kind of end user consumable. It's not really gonna. All right, fine. That's fine. So if we grab the bar and then say bar, so the first one is the label that's going to be shown in the history. The second one is the field accessor. We can actually see as we call that, we're going to get back a tracker, which instead of having the type foo, tracker foo, now it has tracker option bar, because by default, this thing is designed to work with nullability. And because bar is not explicitly able to be told that it's not nullable, we just assume that it is nullable because by default, everything in the Swagger parser is actually nullable. So we just don't take any chances. We just pull out the option bar and say, you know what, here you go. Here's your option bar. Now, that being said, if I wanted to stop and consume this right here and now, I could say raise error if empty, expected a bar, got nothing, right? So I can just call that, and what I'll end up getting is a target value. The target value contains that error message, right? So if we ended up raising an error, this is taking the optionality of that thing and raising it up in guardrail's target monad and saying, look, I don't I don't have a way to handle this here and now, but somebody else somewhere does. And that would be the job of the interpreters in guardrail, to take that error and raise it and surface it to the user in a useful way, giving us just a normal target value. In this case, because we actually had a field, the field was present, we end up just with a normal target value. And also we can see that the tracker here no longer contains an option. This is just a straight tracker with a bar inside. And this gives us the ability to say map this down field value, or rather B, and then that B. And we can see that we're going to get a target of tracker option Baz again. So the trying to traverse into that next field inside this target, we ended up having to, first of all, map multiple times, because now we're in the target context and the tracker context. So if you're in a target context already, you can actually use this sort of just straight map, like getting the values, raising errors as you go, which is possible, but it's not very convenient. What we can do instead is actually call, instead of this map downfield thing, what we can do is we can actually say flat downfield, which is sort of spiritually analogous to flat map. In this case, it's sort of flattening the fact that the outer thing was a tracker of option, and the inner thing is also going to be a tracker of option. It uses convincer to try and figure out what the types are and make sure that they align. It has some magic as well in order to make sure that the types end up getting close to what you want generally. In most cases, it does what we want. I think in all cases, it does what I want. But if it does something that doesn't work with what you expect, then definitely raise that as a bug, because that's not intended. We can see that actually here as well, where first we started with an option of bar, right? And then we went to this B field to get an option of Baz. But Baz, as we can see in our example above, Baz has a value field, and the value field is an array of string. So if I say flat down field here and say value, this value, I don't really want an option list of string. What I want is a list of string. That's because the flat here is sort of doing the same thing that flatmap does in Scala, of the Scala collections library, of just sort of not really join traversable or any of those sorts of things, but instead doing more massaging the types to be generally compatible with what average use cases would end up dictating. So we end up with a situation where we end up getting a tracker list of string instead of what we otherwise could have gotten, which is an option of list of string, which is fine. There's nothing really wrong with that. It's fine that we're doing this index into optional values and transforming option list into like flattening the options together, flattening the options in the list together, because in most cases, all we really want to do is get the sequences of fields out of these Swagger structures and map those into case classes or fields or constructors for objects and things like that. So as a result of that, transforming this into a tracker of list string is very useful, primarily because we can actually do something cool, which is called indexed distribute. And what that does is that actually inverts the list and the tracker. And so that actually pops the list out of the tracker and also puts the tracker's history inside the list. So you can think of this as sort of a traverse sort of structure, except it's not quite traverse, because traverse doesn't give any sort of indication as to exactly how it's doing what it's doing. This is by design. There's no real need to know the structure of the thing that you're iterating over or kind of traversing into. But this is one of the reasons why we couldn't just use standard traverse, foldable, whatever, because it didn't provide enough insight into the structure. We can see here the list that we end up with, if we for each print line here, we end up with a tracker of the individual string values. These are actually the values that I've constructed here in this new BAS. But the vector actually preserves the history of how to get to that thing. So we started with this bar index, then a B, then a value, and then index 0, 1, and 2 for each of the sequences in the list. This ends up being super useful when dealing with things like different content types are represented as maps now, but for instance, enumeration values, being able to say, so the sequence, the string defined at enumeration value like 3 or 4 doesn't match, it's not representable, or there's a duplicate element or something like that. It's invalid in some way. Instead of just saying, well, there's a problem with your enumeration, instead being able to say, this is exactly where the problem is, go and fix it, and then come back when you're ready, ends up giving us really useful error messages. So we can actually see this in the first element. If we say history, I think it's, there's 2 different history accessors. One of them is, history is the vector, and then show history actually gives us the string representation of that thing. And this can just get tacked directly onto any error messages in your code. So you can actually see here, if we alter this slightly to have a null at the end here, and then rebuild this, I think, so because, let's see here, this text, tracker foo, vector that. Okay, so if we then downfield into all of these places, I think AB null, that's unexpected. So there's your tractor. Oh yeah, no, that's actually correct, because we haven't indexed distribute yet. So okay, so there you end up with the, actually that's a bug, because this should have been able to recognize that that null should have gotten flattened out or turned into an option. So yeah, there's work to be done, I guess, but at least for now, that's sort of, no, it is disappointing. But anyway, point is, the intent here is to be able to say, if we access the like the second field in this list, we can actually see that if we map option that, right? So if we map option apply to raise this back into a tracker of option of string, and then we raise error if empty, and I say there was a an empty object where we expected something, right? So we just raise that, and then we end up getting a target error with this, there was an empty object where we expected something, but, and a really useful error message of, this is exactly the path, and that's just built in. This would end up showing up as a guardrail warning or error message. So if we actually exit out of the shell here and run the Scala example, so run Scala example, so we end up with this, we're going to run the whole CLI suite, right? So just try to generate all the regression tests based on the Swagger specifications. But what we end up with is we will see a warning, sure enough, deprecated behavior, unsupported binary type for blah, 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 blah. Here at the end is our error message coming directly from Tracker. This happens automatically. We actually don't have to worry about that at all because we threaded tracker all the way through the code base. We can actually look at the, this is, the one thing that this doesn't do is this doesn't actually tell you what file it's coming from, and that, I guess, is a problem. But the idea would be format binary coming from, yeah, okay, format binary, and that's going to come from a single YAML file. Sure enough, this is binary, yeah, binary. Okay, cool. So it's likely this one, right? So if we look at the paths, there's foo, there's operations, the default index into a path is operations. We can see post, responses, here's our 200 content, application, octet stream. By default, this is this wrong? Foo operations, this may actually be the wrong file. Because I expected, yeah, this is better. Going back again, oh, this is pet though. Foo post, this is image PNG, image JPEG. Well, the one other thing though is, as we are experiencing now, this is almost certainly the file that's generating this error. But because this is a Swagger, like OpenAPI 2, and we're using the Swagger 2 to Swagger 3 converter, it's treating the error messages as if it were coming from an OpenAPI 3 specification file, not Swagger. So we can see that the consumes and produces here are actually defined at the top level. They end up coming in here in this application octet stream. They actually come from this up here where we're saying, look, everything in this file is going to be an application octet stream. This is a limitation in Swagger. But as it turns out, they've sort of fixed that limitation. So we end up here looking at the schema for that thing. We end up with a format binary. So we had to sort of play a little bit of gymnastics in our head to try and figure out exactly what this mapped to, but at least it got us closer to the ballpark instead of just saying there's a problem with your file. I don't know how to help you, buddy. So this is why this was written in the first place, I guess. Or feel free to ask any questions, open issues on GitHub. So yeah, thanks for watching. Later.